Good afternoon, everyone, and a very warm welcome to today's webinar on connecting energy monitoring, predictive maintenance, and sustainability for resilient operations. I am Pragya Gupta, Product Marketing Manager at Neilsoft, and I will be your host for today's session. On behalf of the entire team, thank you for taking the time out of your schedule to be here. We are delighted to see such a diverse audience joining us from across industries. It truly demonstrates the critical importance of energy, efficiency, asset performance, and sustainability in today's operations. Over the next hour, we will explore how organizations can move beyond tracking consumptions to truly optimize energy use, predict equipment failures before they occur, and align operations with ESG goals. Before we begin, just a few quick notes. This session is scheduled for about 60 minutes, including question and answer. Please feel free to drop your questions in the chat anytime and we will address them during the question and answer session at the end. Now, let's introduce our speaker for today. We have Mr. Parish Rao, Vice President, Pre-Sales and Delivery, Neil Automation with us. Welcome, Mr. Parish. He has a 25 plus years of experience across a wide range of industries in the manufacturing IT domain, which includes metals and mining, food and beverages, consumer packaged goods, water utilities, power utilities, oil and gas, and pharmaceuticals. Experienced business leader with extensive expertise in sustainability, digital transformation, and business development. He is skilled in strategizing, planning, designing, building, and scaling global business teams to drive large scale transformation programs. He is recognized for the ability to establish and grow business practices, lead cross functional teams, and deliver measurable results in highly competitive IT environments. So, without further delay, let me hand it over to Mr. Parish Rao to take us through the first segment. Parish, over to you.
A very warm welcome. Good afternoon. I hope I'm audible. So before I start with, a lot of questions would arise in terms of why we have taken up this topic. So especially when we are talking about any operations, whether it is a manufacturing operation, whether it is basically a building, or whether it is any systems, what we are talking about, the resilience is what basically people are looking forward to. So how fast? So when I say resilience, how the resilience is the ability of the the plant or operations to quickly adapt to and recover quickly from disruptions while minimizing the loss of productivity or revenue. So if we have to specifically point out what are the key three reasons which directly or indirectly affects the operations, energy is one of the very one of the prime things comes into the picture. The another part is basically the asset performance or the asset maintenance part of it. And thirdly, right now, if I have to point out something which is very important, it is sustainability. So overall, we have a system in place, Power Optimus, which is basically covering up all the three things. And this basically helps you in the decision-making process, especially for the resilient operations. With this, I will take you through in the next half an hour. I'll walk you through the entire Power Optimus as a product, and then I will have a quick small video about it, and there will be a small demo followed by question and answers. Sorry. Yeah. So when we talk about why energy monitoring matters a lot, so you on the left hand side you can see the current energy consumption or the energy requirements of the world is approximately $2.4 trillion, and the amount that will be spent over the next in 2032 would be approximately $3.5 trillion. So you can imagine the energy guzzling requirements is increasing day by day, whether it is for a data center, where new setups being done, or whether it is basically for a manufacturing plant which is catering to different requirements. The energy requirement is not going to reduce. You are going to have new plants coming in, especially in India, where we are now focusing more on energy, on manufacturing as well as data centers. This is going to be a area of concern for everyone. The cost of energy is not going to reduce. The energy costs are always going to increase. So as you can see, the what are the key drivers? The energy costs would be the key drivers for any manufacturing, because it is going to decide how profitably you can operate. Because with rising costs, you may not be able to pass it on to your customers, and this is where, if you are not able to understand what is your energy consumption currently vis-a-vis your current production, vis-a-vis your current systems, this is basically what is going to matter. Whether it is for a healthcare, whether it is for a data center, whether it is for manufacturing or for a standalone building or a commercial building, energy matters a lot. Especially now, the other key driver is regulations and incentives. So as you can see, there is a lot of emphasis on green energy. There is a lot of emphasis on solar energy, wind energy, to reduce the overall cost. And how this fits into the overall scheme of things is basically is what is one of the key drivers for you. The other thing is basically the technology advancements, things which were basically in the past some years back is no more applicable now. We have a lot of sophisticated products available, a lot of sophisticated systems in place now with the advent of IoT, Industry 4.0. There are a lot of devices which can be connected and can be remotely monitored, and this is where energy monitoring comes matters a lot. Especially, you can see from the top, the energy management system market is projected to grow from 38.8 billion in 2025 to more than 101 billion. So that means there are a lot of people who are ready to spend a lot of money for monitoring purpose. So this is where the energy monitoring market is moving, and this is where like energy monitoring has a big vital role for everyone. Now coming back to the other point, which is basically the ESG. So as you can see, ESG. So as you can see, ESG is one of the key factors, basically considering that lot of emphasis on green energy, net zero carbon. So all of this basically somewhere we'll have to start, and this is where like you can see a lot of emphasis on reporting what is your current carbon consumption, what is your overall in terms of how you are performing from the environment sustainability governance perspective. So this, as well as the regulatory requirements. So as you can see in Europe, they have started putting in a lot of tax on the the goods that is getting exported, and these basically is nothing but the green carbon tax, what they call it. So all of this, as well as even the consumers expectations in terms of how they are contributing for the environment, how they are basically ensuring that they are buying some green products, these are the strategic drivers basically which is going to drive towards moving towards the ESG. And as you can see, majority of the manufacturing or majority of the buildings would like to adopt to the green environmental norms, because one, it saves the cost, it saves the operational expenses, and at the same time they are following most of the requirements what is laid out by the government. So with this, basically, as you can see, ESG matters a lot for us. Now coming to the next. So coming to the next point of predictive maintenance. So how this fits into the bill. So the assets, especially when we are talking about especially when we are talking about any asset, we would like to utilize this asset as long as possible, so that this asset contributes to the bottom line of any company. So if we have put in efforts to put a plant, we would like to utilize them as much as possible. So how this is possible? like suppose if someone is coming up and saying that my energy utilization when I started my plant versus what it is now 10 years down the line, how will it look like? Of course it is going to change. Why is it going to change? Because one, especially the machines are no more the same. They are old enough, and basically they are going to guzzle more energy than what when it started with. And basically this is where the maintenance strategy matters a lot. And with the advent of systems, with the advent of a lot of data, utilizing this data and then predicting formulas as well as algorithms that are there in the market, this becomes much easier to create a predictive maintenance strategy. And this is where, like, if you see the graph pie chart, the predictive maintenance matters a lot for companies because one, there are shortage of skilled technicians, lack of proper trainings, maintenance strategy is failing a lot, especially the equipments are quite old or poor equipments, lack of time for performance. Then there are operational related errors, and then there are a lot of mechanical failures happening. And the biggest contributor of all is basically the aging equipment. So with this predictive maintenance, as you can see, we want to minimize the overall downtime. We want to extend our equipment life. And of course, we want to have the operational efficiency and productivity. And now that focus is on smart manufacturing, of the data which is basically coming in from the shop floor, how this could be utilized, analyzed, and then we can come up with the predictive maintenance so that it basically helps in the resilience of operations. So suppose if a particular machine is down, it is only contributing to your lessening your bottom line rather than basically helping you in that. So this is where most of the strategies are around three areas. So energy management, second one is basically sustainability, and third one is basically where the maintenance part comes into picture. Now especially how we correlate with the power optimus, because this is where our product, what we are talking about, is going to help you. One, for the energy management, it is able to get the real time energy consumption. You can do a complete real time energy consumption, whether it is at a product level, either at a shop floor level, either at whether it is at a building level, whether it is at a data center level. You can drill down to every insights to the equipment level. You can identify the inefficiencies instantly. You can identify, enable a smarter energy decision making. Whether it is getting the energy from the solar, whether it is energy from the wind, or whether it is from the grid. So this is where energy management helps you identify the bottlenecks, identify where exactly you're going wrong, and what can be done properly for you. Then comes the predictive maintenance. So it is also, so it is basically detecting the anomalies in the energy, vibration, and temperature. We have added one more element into it, which is basically the uh, element of measuring the noise around, and so that we can identify how this noise, vibration, temperature, energy uh, has its effect on the machine, and how this could be overcome in timely maintenance, timely inspection, and timely intervention. Basically, the entire premises is basically to avoid the costly breakdowns and extend the equipment lifespan and reduce the unplanned downtime, so that uh, um, as everyone knows, that a breakdown is more costly than a plant maintenance. A very good example for everyone is basically your car. In case if your car fails in between, you are stranded, you need to call in the required maintenance guy, or you may have to tow it, and then the efforts which is required for doing all of this is much costlier than basically having uh, a maintained vehicle. So this is where we always have an emphasis on basically predictive maintenance, sustainability, and ESG impact. As you know, uh, the every government, every country has their own the tracking process. You have to report the emissions, you have to report the different sustainability goals that you are basically adhering to for that particular country, especially the CO2 emissions tracking and reporting, waste management part of it, and aligning to the ESG goals of the country where you are trying to export. So if you look at it, we have this single solution which takes care of all the three elements of it. So what is the basic benefit of it? If you look at it in the three buckets with this integrated, of course, it starts with the environmental benefits. You have a lower carbon footprint with reduced scope 1 to 3 emissions. Why? Basically because you are in a position to understand where exactly you are consuming more, what you are doing, how much is your carbon consumption, and then what you can do to make it lower that. And of course, with this, you are also in a position to use the resources very optimally with reduced waste and also reducing the pollution. So it also affects your operational benefits. So in terms of costs, the energy and the material efficiency, basically. So if you are in a position to understand how much is the cost of your individual product, or how much you are consuming for your, per person, what is your consumption for a building. So this is basically going to help you define the benchmark, and then how you can, really reduce the costs, especially in terms of equipment failures, wasteful energy consumption. So then there would be times where you will see that, some of the machines are running without any load on it and still consuming the energy. You might be seeing that there are buildings where the ACs are on. There may not be people around, and you still, you are consuming, you're you are wasting this energy because it's very limited, and in spite of that, basically you're paying through your nose for maintaining the building. Improves your asset performance with analytics and optimization. Of course, all the compliance related issues, if we are talking about, so we have a lot of compliance related reporting that is possible. All of this basically is captured through the data and through the sensors, and in a position to be, streamlined and made available to all of you for reporting purpose. In terms of business and strategic benefits, you will see that you are enhanced. So ESG compliance. So most of the ESG reporting formats we are compliant to, and you would be in a position to do it at a click of a button. And especially nowadays, when you will see that a lot of green financing taking place, and with the type of ESG supporting us, we would be in a position to get a lower cost, in terms of the business would be able to get capital at a reduced cost. Of course, the brand would have a higher positioning among the people, because people will start seeing us as a sustainability leader. And future proofing, where everyone is moving towards net zero, this is basically where we are going to see a lot of benefit for the business in the long run. So how do we do this? So we call it as a three lens approach. So basically it is a framework used to analyze any complex systems from multiple perspectives, often tailored for any specific domains. When it is applied to energy, assets, and sustainability, the lens refers to the interconnected pillars of environmental, social, and economic performance. So how do we do that? We again baseline it. So basically it starts with baselining, trying to understand the assets, trying to understand your energy consumption, trying to understand the sustainability, how all of this three you are currently performing vis-a-vis the rest of the industry, or where exactly you stand. Basically trying to identify what data you are basically using for the operations, and then coming up with the reactive to proactive decision making. So this is basically where what we call it as we try to visualize it, understand, and then create a data layer, basically creating a reactive to proactive decision making. Now coming to the value identification. So when we are basically approaching, or basically when anyone who is basically approached with this, we look at it from the three lenses of value identification, which is operational cost lens, controlling. So basically, when we say operation cost, we are talking about what are the processes which is basically driving or which can contribute to the bottom line, how this is basically going to help produce more with lesser cost, and especially in terms of controlling lens. So understanding, once you have the understanding of the data, you understand that what exactly you want to control and how you will want to control it, and how this could be controlled, whether it is automatic, whether it is semi-automatic, or whether it could be a manual, and then prioritizing which basically is going to contribute to your bottom line more. And this is basically where the value delivery takes place: analysis and prognosis of the key areas of improvements, and then logically grouping of the assets and prioritizing for the implementation and operational efficiency. One of the key things about the Power Optimus is that it is already a BIM compliant. So when I say BIM compliant, as you can see, the majority of the new age buildings or majority of the new age plants basically is already having are made with softwares which is basically having business information modeling. And this is basically where we are saying that we are already compliant and we can help use that 3D models, and we can use the data which is coming in from the BIM to showcase how this is basically structured from the perspective for a customer in terms of how this data could be understood layer by layer for the customer. So what are the key features of Power Optimus? The very first thing what we normally tell to the customer is basically it is a complete configurable and scalable system. Whether you are doing it for 10 systems or whether you are doing it for 10,000 systems, it is completely configurable and scalable. So whether it is for a building, whether it is for a plant, whether it is for a machine, whether it is for a data center, or whether it is for a healthcare center, irrespective of, the same system can work. It can talk to multiples of systems. It can talk to multiples of sensors. It can connect to different components. We have multiples of drivers where we can connect to, and basically it can streamline your data, and this data which can be used for analytics purpose. So it can be used for monitoring and control purpose. So basically all the key elements of data, when you are getting the data, you should be knowing how this data is going to perform for you or how is it going to be controlled by you. Of course, you can have interface with the external systems. You can showcase, you can control the different controllers through this external interface, and you can also depict your data to different systems in case if you have. So whether it is interfacing with your ERP, whether interfacing with your MES, or whether it is interfacing with your SCADA systems, we can do that. And that is where we call it as a flexible system. And of course, at a cherry at the top is basically the analytics and alerts systems. So we have already done a lot of work on the analytics part, and there is a lot of work in progress to enhance this analytics so that it can be used across for different customers. Whether you are in a design phase, whether it is in the commissioning phase, or whether you are in the operational phase, the Power Optimus is basically providing a lot of cost benefit to you. So when in the design phase, we can help you with the energy requirements, understanding the alternate source, and how the cost benefit analysis can help you. So that the Power Optimus, when you are putting in place, this entire thing can help you in the various sets of operations. And during the commissioning phase, installing it and then connecting it to different systems is basically where we can help you. Operational phase is basically where we can help you deep dive and find out the opportunities using this Power Optimus, which are the high consuming elements. So in short, irrespective of in the design phase or in the commissioning or in the operational phase, is where Power Optimus can be very helpful. Now coming to what is the key element of an EMS system. So if you look at the Power Optimus over here on the left hand side, so it is agnostic, factories, industrial plants, buildings, or healthcare. It is applicable for all. It can talk to um, any energy systems, gas meters, environmental systems, whether it is basically NO2, SO2, or oxygen meters, or solar systems, or grid monitoring, or building monitoring, or it can connect to any meters, and it has got remote connectivity, Wi-Fi connectivity. It can connect through any industrial standard protocols that basically you talk about. We have already built in some of the very standard protocols like OPC UA, MQTT, whether it is Wi-Fi, whether it is Modbus backnet. We have LoRaWAN. So you talk about it, we can connect any devices, meters, systems directly. Of course, it has got IoT node or IoT gateway and the data fabric. So basically, when we say if we want to connect to a cloud system um, or complying to any specific requirement, this is basically where we can help because it is already compliant and has got the basic framework in place. And of course, the as I told, it has got a graphical feature GUI where you can see, customize, visualize, analyze, take quick actions, and also at the same time you can do deep dive analysis of how or what exactly is going into your plant. So in short, basically it covers up the device connectivity, IoT hardware, industrial standard protocols, data acquisitions, visualization, analytics, and it is sticking into every aspect of it, or any third party IoT hardware. And of course, nowadays you will see that there are a lot of hardwares wherein you may not be able to connect it, but we are in a position where we can help you connect to the systems. We develop our own systems basically, which is going to help you connect to this, and it can directly connect through the Power Optimus. Now coming to so basically when we say for sustainability goals, so it is basically covering up 17 sustainability goals targeted by United Nations, out of which 4 are directly supported by this Power Optimus. And basically I would be talking in a bit more about it. Like one of the goals, which is 7th number for United Nations, is ensure access to affordable, reliable, sustainable, and modern energy. So this is where our Power Optimus tool has got all the features for energy efficiency, supporting the renewable integration, cost effective and affordability, data governance for clean energy, and stronger facilities with predictive care. Building a resilient infrastructure and drive sustainability industry and foster innovation. So this is basically where we help with the infrastructure for sustainability, resource utilization, improving the resource use, and efficiently utilizing most of this in the infrastructure, which is basically so. Innovation is basically where we are like it can basically fit into old systems or a new systems or any future ready systems, and supporting inclusive industrializations, ensuring a sustain. So 12th number goal from United Nations is ensure sustainable consumption and production patterns, and this is where like the efficient energy utilization and resource utilization, predictive maintenance and waste reduction, sustainability reporting and compliance, life cycle and behavior change impact, and operational optimization basically is where we are helping in the some of the goals of United Nations. And of course the climate change, where basically enabling carbon footprint, mapping the carbon footprint, reducing the energy related emissions, resilience and adapting. to different environments. So, in short, basically, we are compliant to 4 of the 17 United Nations sustainability goals. Now, coming to the question of how we help our customers. So this is where like we start with the discovery and definition phase, especially in terms of the maturity assessment. We try to understand the business landscape. We do a what if analysis. We create a blueprint exercise, and then we do a complete understanding of what the customer wants are and what exactly is the ask. Then we basically prioritize working, basically where this is where we do a use case selection. So we prioritize what to solve, how to solve, and know your premise, what could be the outcome once we do this. And this is basically what we call it as a use case selection. Now that the use case selection has been done with especially the low hanging fruit, we work towards implementation of it. And this is where like we try to come up with the framework for decision making, especially from the customer perspective. What is the tech stack? How the tech stack could be basically strategized, how this could be improved, how we can do any specific custom requirement could be, or taken into the framework. And then once all of this, basically, if the system has been made available and we are able to track this, we work towards realizing the benefit of it. So, from the perspective of how it could be scaled. So, earlier it was for a proof of concept, then moving towards a grander scale, consistent, and then consistency, coming up with different reporting patterns, identifying the KPIs basically. So, this is where basically we are helping our customers. And finally, at the end, once this tool is up and running, providing them with the hypercare, ensuring monitoring and management support, helping the customer learn through the different analytics tools, etc. So this is basically where we do. Who can be our partner? Of course, it can be corporate buildings, it can be hospitals, residentials, warehouses, data centers, manufacturing plants, oil and gas power generations, food and beverages, pharmaceutical plants. So it can be anyone and everyone because this is very agnostic. It can work on different drivers. It can connect to your enterprise system. It can connect to your shop floor systems. I'll be just walking you through with some of the examples over here. Um, Especially this is basically for so I have taken 4 different examples in this. One is for the commercial building. So the key challenge for this customer was basically they used to have a lot of energy consumptions, and of course those of you who are not aware of, I'll just try to tell you the major consumption of energy in the world is for the buildings. It is not for manufacturing. It is not for anything, but it is basically for the commercial buildings, because this is where almost 75% of the people are working in the world, and this is where you are consuming a lot of energy for lighting, HVAC systems, and facility. And this is where the customer also had the challenge that the cost was going up on a day by day. How they can come up with innovative way by identifying. See, if you go to any building, you will always find a building management system, but you will not see energy management and then coming up with the efficiency or basically tailoring it to very specific. So this is where we came up with the solution. Power Optimus was put in place. It helped create occupancy-based adjustments using motion sensors to lighting and HVAC in unused areas, identifying the air quality, monitor and improve the air quality for employee productivity and well-being. It also included lumens-based lighting systems so that in case if the number of people are more, the lighting systems could be improved. And of course, data-backed insights for green certification like LEED. We had implemented motion sensors, lighting energy core. We have seen almost more than 5 to 6% reduction in the energy consumption over the period. So this is basically a Japan-based customer. Um, this is basically for the facility industry, and of course, the key requirement was machinery and production lines, and requiring proactive maintenance strategy to avoid costly downtime. So, as um, if those of you in manufacturing, you might be knowing that in case if the energy consumption is going up, that means basically there is some problem as compared to. So if you have the data and you have the ability to understand it, the key aspect is whenever the energy consumption goes up, either there is a problem with the raw material or there is a problem with the machine. And basically, this is where the energy consumption, along with the various other parameters, basically were tuned towards predictive maintenance using vibration sensors to detect early signs of wear and prevent, especially from the energy savings perspective. So, optimizing the processes in terms of heating, cooling, and lighting, this has resulted into a substantial reduction. So basically, these were some of the three tailored strategy, basically which helped the customer in the long run. Especially in the hazard monitoring, it was more on the CO2, CO, methane, uh, especially because this customer had the problem that they used to deal with a lot of hazard gases, and they wanted to ensure that there are systems basically in place. They already had some of the monitoring systems. We uh, brought it all into a common platform through the Power Optimus, and this is where basically this not only helps the predictive maintenance, basically it is also affecting the energy savings. So in the long run, the customer is benefiting with the Power Optimus. This is specifically for the data centers. As you can see, majority of the customers or majority of the people know now that the biggest energy guzzlers would be basically the data centers, and continuously monitoring of the energy consumption is going to be the key for any data centers uh, profitability. And this is where basically understanding the different sources, understanding the requirement, understanding how it is connected to the building management system, optimizing the cooling systems with real-time temperature and humidity data. Because see, this is not just about the energies. You will see a lot of energy management system in place for a data center, but one of the key things is basically how you bring in a real time data from the temperature systems, real time data from the cooling systems, from the building management systems, HVAC systems, and detect what, how, or where exactly is the anomaly, and how this could be preventing the overall the different sources from where you can minimize your downtime impact, minimize your power consumption impact, and at the same time when you are basically trying to scale. So all of this is basically was helped using the Power Optimus. Now coming to a very specific use case for hospitals and healthcare facilities. So as you can see, it's basically one of the key challenge for our the customers is basically high energy demand from medical equipments like scanning, MRI laboratories, HVAC systems, and lighting. And then the very specific stringent norms for indoor air quality and environmental conditions, because um, this always requires to be, the air should be very clean, the moisture has to be maintained. This is basically where our system came into picture. um, of course, monitoring the energy in the high demand areas, and then identifying the areas where there could be an improvement was one of the key benefits of it. But of course, the environmental monitoring, tracking the air quality, COD, humidity, temperature, lumens, noise pollution, basically, and maintaining a optimal condition for the patients and staff was basically one of the key parameters. And this is basically for a company in US. And especially all the regulatory compliance. So this is basically where, like, we have helped our customer especially for healthcare. Now, coming to how this is basically a swim lane diagram. As you can see on the top, you can see the weather, you can see the pressure, humidity, wind, cloudiness. Why this matters is basically because if you're producing through the solar systems, if you're producing through a wind systems, all of these parameters matters a lot, because you have a clear understanding how much you are going to produce from these renewable sources versus what you are going to take it from the grid, because you will not be always having uh, energy coming only from the solar grid. Now with battery management system, so we have the capability of bringing in all this different sources. As you can see in the swim lane diagram, this is basically the energy coming from the grid, how much we are consuming. You can see it here. And then what is the solar energy that is basically being generated. You can also capture the diesel generator energy at any point of time. And then on the right hand side, you can see where you are currently consuming, which building is consuming more. So you can see operational building, um, for each of the building, how much you are consuming. And you can see the, the DG set capacity, your air quality index in terms of the energy. So if we have all those transducers, you can see it in real time, the different aspects of it. So here in green means basically it is fuel tank is full, temperature is maintained, oil is well maintained in the DG set, energy, basically you can get all the maximum demand alerts. So one of the key aspects for most of the customers is how much energy they have uh, targeted to take from the grid versus how much they are really consuming. So that in case, as you can see, in case if you're consuming even 1 kilowatt extra, you have to pay a penalty for it. And in case if you're exceeding a particular target, the biggest challenge, especially for the manufacturing or a building or anyone who is contracting from the grid, is that the next billing would always be having that particular as the targeted number, and you have to pay more all throughout for the next 6 months. So this becomes a tricky situation, and this can be a do or die situation for a lot of customers. And this is where we help manage the maximum demand, um, especially also, of course, on the lower side you can see the different stages, where exactly locations from different floors, what is the temperature, etc. This is basically giving you a glimpse about the luminance. So it is basically telling you for each floor how currently the how exactly is the luminance level, how many lights are on, when it was on. You can see in the graph, at what time was your highest luminance versus what time is it tapering. Similarly, what is your overall power, differential pressure in the systems, air quality. You can see some of the PMI graph over here. You can see the noise level in the premises from each floors and each buildings, each levels. You can see all of those, and because these are some of the things that you need to report to your from the environmental perspective. Now, talking about the building management, so basically how it is integrating with the existing building management system. The majority of the customers who come to us, they say that we already have a building management system in place. Now, how are you going to integrate it? And this is where we say your existing building management system is only going to take care of certain aspects of it. This is basically where we are helping them take care of the ventilation equipments, because majority of the heat source equipments, air conditioning equipment, sanitation equipments, disaster equipments or electrical equipments are managed by the building management system. We integrate it closely. We integrate it through backnet. We integrate it with backnet SC. We can integrate it with OPC UA. and can create a single source of truth. And then those where there are new systems to be added, we can add those and provide a complete view of every layer by layer, so that you can deep dive into it. You can see outliers, and then you can see workflows basically. So it will send notifications to the right people on action to be taken. It can also help in controlling also. So it's just not a monitoring system, but it is also a controlling system, because it is helping you take action. So in case if we have AI based algorithms which has been trained, we are in a position to control after what time that the system should automatically switch off. All of those basically is possible. It can integrate with the PLC. As I said, it can integrate with the northbound layer as well as with the southbound layer, without having to compromising on human aspect of it. Now coming to what are the key takeaways. Of course, it is energy monitoring improves the visibility. Predictive maintenance basically ensures reliability. Sustainability goals drives long-term success. Informed decision making is basically what we are targeting, and basically what we are in a position to do it. And of course, the integrated approach is equal to resilient operations. How it has benefited, we have seen our customers getting 8 to 10% energy savings within a shortest possible time. Of course, reduced downtime with predictive alerts, of optimized equipment performance we have seen, improved sustainability compliance, because most of the reports are off the shelf and there are a lot of reports which we can comply to. There are a lot of smarter operations, higher return on investment, and standardized reports. With this, I'm ending the presentation. I'll just shortly show you a video.
As facilities grow more complex, managing energy and environmental impact is not just a challenge, it's key to long-term resilience and sustainability. Power Optimus is a smart, data-driven platform built to optimize energy use, monitor environmental parameters, and enable predictive maintenance for future-ready operations. Modern facilities often struggle with energy spikes, inefficient source switching, comfort inconsistencies, and unplanned breakdowns. Power Optimus turns these challenges into opportunities. Through smart sensors, real-time dashboards, and seamless integration with your building systems, Power Optimus provides end-to-end visibility and control. Whether it's real-time energy tracking, switching between solar and grid, or monitoring air quality, Power Optimus enables data-driven, sustainable decisions instantly. By aligning performance with sustainability goals, it helps future-ready facilities reduce their environmental footprint while enhancing resilience. Facilities powered by Power Optimus have reported significantly lower energy costs, consistently comfortable indoor environments, and improved equipment reliability. With enhanced visibility and intelligent control, operations become more efficient, proactive, and aligned with long-term performance and sustainability goals. With Power Optimus, your facility doesn't just function, it performs. We believe real change begins with collaboration. By transforming vision into concrete progress, we're not just imagining a better future, we're building it. Together, let's power a world that's efficient, resilient, and sustainable. Together, we'll drive your long-term success. Ready to power a smarter tomorrow? With the right insights and technology, efficiency isn't just possible, it's inevitable. Let's talk and explore what Power Optimus can do for you.
Thank you.
Thank you, Paresh. We have Nilesh with us who will show us the implementation that we have done in the Neil Automation Facility. Over to you, Nilesh.
Okay, thank you, Pragya, and thank you, Parish, for explaining the details of energy analysis and power optimization as such. I hope I'm audible.
Yeah.
Okay, fine. Thank you. So, good afternoon, everybody. Hopefully, you can see my screen, and this is the main screen of the Power Optimus platform. You have seen most of the glimpses of this in the last presentation. So, as you can see, we have mapped the local NeilSoft facility here in the form of different buildings. As you can see, on each building you have different floors, and on each floor we have different kind of sensors in the form of temperature, humidity, noise, and whatnot. We have so far implemented around 10 to 12 different types of sensors. On the homepage you can see we are monitoring the weather, the local weather, the air quality index. We also have some BG sets and energy for which different alerts and different recommendations have been made here. And then you have something that we call as monthly energy distribution. So what you see on the left is actually the generation of the energy versus the consumption of the energy in different buildings. So that gives you a glimpse of how much electricity we are pulling from the grid, the electricity grid, and then the solar and diesel generator. So just a concise view of what is the use that we are making. And then we have solar panels. So on solar panel you can see the real time data here. So far how much energy has been used. You can actually use this data for a lot of analytics. I'll be showing that some of that into the analytics as we discuss. And then we have the grid power chart here. So on grid power you can see this particular level. So this is an MD level. So how does it help us is in the sense is that um, if you have this energy approaching this particular level, it will automatically trigger an email to the admin team, and they can take corrective action. In terms of economic value, this helps us a lot. The reason being, if your level or the consumption of the grid it exceeds this MD level, then there'll be an additional charge levied by the electricity board to the company or to the particular enterprise, and that's a significant amount. No? So these kind of alerts and notifications can be triggered from the system. In this system, we have installed around 100 to 200 sensors, including all the buildings that we have. And this kind of configuration or this kind of tree can be developed. So if you have a tree of this kind in any format, in Excel or JSON format or anything, it can be implemented into the system and can be a day's job to develop this. And then there is a background framework. When I say background framework, it means installation of the sensors and configuration the sensors, which is quite a dynamic approach. So you can actually configure the sensor in the real time, and you can see that live in the particular system or in the Power Optimal system. Now I will go through some of the entities that we have mapped in our building. So we have energy meters, power meters, mapped at a particular floor. If a particular sensor is not working, it shows this kind of alert, and it will also trigger the admin that some sensor is not working or there is some problem with the particular sensor, and you can actually see the data in the real time. Now all of this you see here is configurable, so you can actually add the type of chart that you want. You can add power chart, you can add energy chart, you can add temperature, humidity. So whatever kind of sensors you have at that particular floor, you can add to the floor of interest. And then we'll jump to another interesting thing wherein we have mapped some more sensors. So the system is sometimes a bit slow because of the Wi-Fi issues and all. So this is another floor that we have, for which we have mapped the power and the energy. And then we to floor. So far we have seen the energy and the power, and then we have mapped temperature, humidity, and noise sensors, and some of the pump statistics into the system. And most of these can be seen into the system. Okay. So as you can see, for this particular floor, you see that for there is different color to different graphs here. Now these colors indicate that you have some problem with that particular sensor. So we have in the background the analytics engine which is running, and we also have certain threshold set for the particular meter. So if the levels for the particular meter are exceeding, then you will see that it is glowing in red. Or if it is just near the threshold, then you will see that it is in soft orange color. Now I'll just explain the analytics engine that we have. So within the analytics engine, we have developed the predictive maintenance framework. So in this predictive maintenance framework, as you can see, we have mapped pump room, elevator, industrial machine, energy devices, and HVAC cart. Now within each of these, we have further parts. So let us say if you have a pump room, you have shaft, belt, pulley, bearings, impeller, and then if you say elevator, you have control system, motors, and brakes. Within motors, you may have different kind of motors depending on the type of part that you want to analyze. We are able to analyze the kind of motors or subparts. As you see here, there are different kind of motors. You can just select one of them, and then you can say the features which are available. So maybe a certain organization may not have all the sensors which you see here. So if you have limited sensors out of this, you can just select them, and you can actually train an ML model on these data. Once this ML model is trained, you can feed in to the system another set of inputs, and based on that inputs, actually the system can tell you the output. The output will be in the terms of like whether the motor will be able to sustain the particular input that you have given to the system or not, and it will be sustaining that particular input or not. So basically the kind of power levels, the kind of voltage, current, speed, or whatever it is, you can just feed into the system, and it will tell you. So this particular framework, for the neural network or advanced algorithm like random forest, it can give up to 90 to 95% accuracy. And this is a predictive maintenance framework that we Parish also explained in one of his presentations. So I think that's all from my side. Any questions?
Okay.
Well,
Thank you, Nilesh. Now we can go ahead with the question and answer. So we have uh, 3-4 questions. Uh, like, can this solution work where there is no existing BMS or any monitoring system?
Yes, there is. Basically, you don't require a BMS system. We provide sensors. We can visualize. We can understand your requirement and come up with the right sensors which is required to make it possible. In case if you have any energy, already you have any energy monitoring system, we can do that. If you don't have it, we can make it happen for you. And if you have any specific set of parameters, KPIs that you are looking forward to, we can work towards getting that and get those things possible.
Okay. Uh, Moving ahead, we have another question, Parish. Can Power Optimus be implemented for existing facilities?
Yes, as I said, the existing facilities, irrespective of whether you have a BMS system, whether you have a BIM or not, it can work easily. We are currently doing it for from one of our customers, and though this is a new facility, but the challenge with the new facility is that they had not thought of it before, but now as an afterthought they came up with having a system in place. So we are integrating the BMS system, and we are also putting in place all the different sensors so that we can have all the environment monitoring etc in place. Yeah.
Okay. Moving ahead, another question is, does this solution support multi-facility and multi-location?
Yes, it is possible. So we can have multi. So we can create a. So we can have a same system can be used for multi facilities, and also have different systems in place for different locations. It can be a cloud hosted with multi tenant type systems. That also is possible.
Okay. Uh, Another question is, can I integrate Power Optimus with my existing BMS, EMS, PLC?
Yes. So basically, our Power Optimus supports most of the backnet protocol. So backnet as well as backnet SC protocol, and as majority of the BMS systems are backnet compliant, so it is very easily integrable, um, and it is possible if we know what exactly is the set of data.
Okay. Okay. Oh, we have one more question. We have one more question. Can Power Optimus convert analog system to digital format monitoring?
Yeah. So for analog to digital, the we will have to convert using devices which can comply to, and then it can convert the analog devices to a digital. So first, basically, what we have to do is understand what's your requirement is, come up with devices which can convert it, so we can identify the type of transducers, type of equipments, basically, which is required. We can do that.
Okay. Okay.
We can
Thank you.
suggest the type of equipment which can go into it. Or we can suggest the type of transducers. We can suggest the type of converters, basically, for the same. Yeah.
Okay. Thank you, Parish. Any more questions? I hope we have answered all the queries. So we truly appreciate your time and engagement during the session. Your participation made the discussion more insightful, and we hope you find this session valuable in exploring how integrated energy asset strategies can drive efficiently, reliability, and sustainability. We look forward to connecting with you. And
For
for
a demo, I think we would be happy to engage with you one on one, and we can show you how exactly it can be done.
yeah, so for more detailed demonstration, please do contact us.